bonds. All right, so everybody understand the difference between ionic and covalent. What if I say a nonpolar covalent bond? What's that mean? Well, I'll give you a hint. The guy up there, does everybody know who he is? CO2. Do we have any of that in the atmosphere? Yeah, that's carbon dioxide. What is carbon dioxide? One carbon, two oxygens. So carbon has 6 valence electrons. Oxygen has how many? Oh, I'm sorry, 5, and I mixed it up. Carbon has how many valence electrons? 4, and oxygen has 6. So what do they need to make each other happy? Well, oxygen needs 2, and carbon needs 4. Can I share some of my pairs? Can we share with each other? Yeah. And we do. We share nice. We share even. Some guys don't share even. Some guys are a little bit more greedy and want the electrons to hang around them a little bit longer in a molecule that they form. And that's this guy down here. He's the greedy guy. This guy is a nonpolar molecule. That means that it's pretty evenly dispersed through the entire molecule. Everybody's sharing even. There's no one side or the other that's a little bit more negative or a little bit more positive. So this guy, carbon dioxide, you can see he shares equal. How many pairs of electrons are being shared between carbon and oxygen? 2 pairs of electrons, and we're sharing equal. He's a non-polar, and what kind of bond is that again? Covalent bond. This guy down here, because oxygen tends to be a little bit more greedy and has the electrons kind of circling around it just a little bit longer, it tends to have a slightly negative end and a slightly positive end. So this guy doesn't share equal. He's got 2 separate ends, or 2 separate poles, just like the Earth, right? What do we have on the Earth? We have one end that's really cold and another end that's really cold, but they're on opposite sides of the planet. We have the North Pole and the South Pole, right? Well, this guy's got a slightly, and that's what that little jiggy mark means, slightly negative end and a slightly positive end. Because even though they're sharing and it's altogether a neutral molecule, the electrons tend to hang around oxygen just a little bit longer. So instead of sharing equal, we see a bend. 2 distinct ends. Did everybody sign the attendance sheet, by the way? Okay. Send that back up this way. Yep. Send it up this way. So we have something called a polar molecule. This is H2O. What's H2O? Water. So water is a polar covalent molecule. Still covalent bonding, still sharing, still pretty neutral, except for the slightly negative and slightly positive ends. And that's going to be really exciting for chemistry. Water is a very good thing to dissolve something in. Does anybody know what the fancy word for that is? It's called a solvent. Water is what we call the universal solvent, because most things are dissolved in water. Does everything dissolve in water? No. Does oil dissolve in water? No. Lipids tend to be hydrophobic. They're actually afraid of the water. But a lot of stuff like, I don't know, sodium and chloride, for example, dissolve quite nicely in water. Because of the slightly negative and slightly positive ends of the water molecule, they tend to attract each other and create a nice attraction from one molecule of water to the other molecule of water. This creates a great deal of what we call surface tension. Anybody ever try to dive off a really high diving board? You're just diving into water. It's nice and soft and cushy, right? It hurts like a son of a gun, doesn't it? Why? Because of that surface tension. Some organisms can actually walk on water because of its high surface tension. Its attraction to each other because of the fact that it's a polar molecule. So it's a very good solvent. It's going to help dissolve a lot of things in it. It holds a lot of heat. It has a very high heat capacity. Remember we talked about sweating last week? Thank goodness we're not sweating this week. It's much nicer in here, isn't it? Yeah. But what was the whole sweating thing doing for me? It was helping to cool me down. When the water, sweat in its liquid form, went into a gaseous form as it vaporized when I fanned myself, what happened? Well, it took away with it, as it changed from one form to another, a lot of heat. Because water has a very high heat of vaporization level. That's a fancy way of saying when water goes from a liquid to a gaseous form, it pulls a lot of heat away with it. Does everybody get that? So water is very important. And they're going to talk about water under inorganic substances in this chapter. Yes? All right, any questions so far? Is this a good place to stop? It's good for me, it's good for you. All right, so we will pick up with chemical reactions.